So, my dear loving students, today I am going to start a very important chapter from class 10, pair of linear equation of two variables. So before starting this chapter, I want to discuss some basic concept of these chapters. What is linear equations? So I give you an example of linear equation. Twice x plus 5y equal to 5. This is the example of linear equations in two variables. Why it is linear? Because the degree of the variable is 1, that is why it is linear. And there are two kinds of variables consist this equation, that is why it is called two variables. So altogether we can say linear equation in two variables. So in this particular chapter, the name of this chapter is the pair of linear equation of two variables. If you consider another linear equation like this, 3x plus 7y equal to 8. And if you consider two equations at a time, then we can say that this is the example of pair of linear equation of two variables. Why it is called pair? Because two linear equations combined here, that is why it is called pair of linear equation of two variables. There are also alternate name of these equations. You can say system of linear equations, or you can say pair of linear equations. Different name also there, but the term is same. That is what the pair of linear equation in two variables. So in class 8 and 9 already we discussed about the geometrical representations of pair of linear equations. Suppose a linear equation like this, x plus y plus 5. If you are to find the geometrical representation of these equations, then you have to find few points from these equations. And if you plot in a Cartesian plan, then we have a straight line. So how to find a point? Just like this instruction. Suppose you want to find the variable of this y is equal to 5 minus x. Then you make a box like this. Then at least you can find 3 points from these equations. Since it is variable, there is no constant variable. So every real value is possible in this equation. You can choose any real value in this equation. So let us choose x equal to 1 here. Then what is the value of y? Very simple. You can solve it. 5 minus 1 is 4. So one of the point of this equation is 1, 4. And if you put 3 here, then 5 minus 3 is 2. Then 3 is another point. Then if you put again and then 5, then this value will be 5 minus 5 is 0. So in this way, we can find 2 points from this equation. It is not that you can find only the 3 points. You can find infinite number of points from this equation, because every real value exists infinite real value. In this way, we can find infinite numbers of points from a linear equations. So just we find only 3. So let us plot the point on a Cartesian plan. For Cartesian plan, we have to draw two perpendicular lines, one in the horizontal directions, one in the vertical directions. So you know about the horizontal axis is known as x-axis and the vertical axis is known as y-axis. For a convenience, we make some equal distribution mark either side of the x-axis with the origins. In the same way, y-axis also we can make some equal distribution mark. Say every unit distance will be 1, 2, 3, 4 like this, and here also the right side, you know, that is negative side, so minus 2, minus 3, minus 4, and here 1, 2, 3, 4, and below the y-axis the origin will be negative value minus 1, minus 2, minus 3, minus 4, minus 5 like this. So let us plot the point from this particular equation 1, 4. So let us locate the point 1, 4. What is the position of this point in the Cartesian plan? So 1, 4 is here. This is the point 1, 4. Then we find the second point of this equation is 3, 2. The 3, 2 is x is 3, then y is 2. and the third point is 50. So if you look at the point 50 here, 50. So in this way, we can plot the point in the graph tables. You can take some equal distinction mark according to your convenience in the graph tables. Now you see these 3 points. If you want to draw a line, easily you can draw a straight line to the points. So that is the geometrical representation of linear equation in 2 variables. So we can take note from this that every linear equation of 2 variables represents a straight line. So let us come to the geometrical representation of pair of linear equation of 2 variables. Since you know that pair of linear equations in 2 variables, linear equation in 2 variables represent a straight line. Since in a pair of linear equation or system of linear equations having 2 same kinds of equations, every equation represents 2 straight lines. The first one is 1 and second one also different straight line represent. So let us come to the geometrical representations of the pair of linear equation of 2 variables. So if you plot few points of these 2 equations, easily you can draw these straight lines. And if you consider different pair of linear equation of 2 variables, we have 3 type of graphics. Let us know what is the 3 type of graphic, what is the 3 type of geometrical representation from the pair of linear equation of 2 variables. This is x-axis, horizontal axis is x and vertical axis is y-axis. So case number 1, in case of geometrical representation, we have the first conditions that 2 lines may intersect. This is the first possible case. 2 lines may intersect. Case number 2. 2 lines may be parallel also. It may happen also. You cannot say that every time they intersect, sometimes they may be parallel. Case number 3. 2 lines may be coincident. We having this supposed to be this line is AB, this is CD, and here it is PQ. And it is supposed to be AB, and here also 2 lines AB, and here also CD. These 2 lines are coincident. That means both lines are same. So 3 possible cases is possible in case of geometrical representation of pair of linear equation 2 variables. Regarding solution, you know a parallel equation can be solved. We already solved different type of linear equation in class 8 and 9. In the same way, we can solve also the pair of linear equation of 2 variables. So regarding solution, we see we have 3 geometrical representation of the pair of linear equations. This is the intersecting line. If the pair of linear equations represent intersecting line, then we have a unique solution. Okay? If they intersect, that is the unique solution. And if the 2 lines are parallel, regarding solution, what can you say? There will be no solution. No solution, why? Because there is no common point between these 2 lines. Here is a single common point, that is P. That is why P is the solution of this equation. And this is the coincident line. So coincident line means 2 equations have infinite number of common points. So regarding solution, what can you conclude this about when these 2 equations are coincident? They have infinite solutions. infinitely many solutions. So regarding solution, we have three cases. One is many solution when this line intersects, no solution when these lines are parallel, infinitely many solutions when the two lines are coincident. So that is about the geometrical representations of the pair of linear equation, and from this how to solve this equation or how many solutions of this system of linear equation we can conclude like this. Intersecting line, any solution. Parallel line, no solution, since there is no common point. Parallel never intersects each other, no. And coincident, they have infinite number of common points, that is why infinitely many solutions. So, for this class, I conclude this here. So, next time, I will give some solution from this chapters. Thank you.